Suppose a handsome young Ben pushes a lawnmower with a mass of 17 kilograms across the lawn with a constant speed. The boy is using 150 newtons of force in order for it to happen. The handle makes a 40-degree angle with the horizontal plane. To begin, we're going to start a qualitative force diagram. We started by drawing a dot that represents the lawnmower, and then we drew the arrows that represent the forces that affect the lawnmower. The first one that we will focus on is force of gravity, which is the entire earth pushing the lawnmower, pulling the lawnmower down. So we drew an arrow down. The second one we focused on was normal force, which was the ground pushing the lawnmower up. So we drew an arrow up, and then we focused on force of friction, which was the opposite direction of the movement, and then the force of the push on the lawnmower. So because we know the force of Ben's push is pushing the lawnmower in the x and y dimensions, we separated the force of the push into the x component and the y component.
Now that we found the qualitative force diagrams, we need to figure out the equations to find out the values for the force of the push on the y-axis and the force of the push on the x-axis. To start, we will draw a right triangle right here and a right triangle right here. We'll mark the angle in both triangles as theta. This angle and this angle as theta. Theta will be 40 degrees. Because this angle is 40 degrees and it's a right triangle, this angle must be 90 degrees. And we know that right triangles add up to 180 degrees, so this angle must be 50 degrees. We also know that this right triangle is also 90 degrees, and this should also be 90. 90 minus 40 equals 50. So that means the last angle must be 40 degrees. Now that we've found the angles, we'll be looking for an equation to find the values of the force of the push in the x dimension and the force of the push in the y dimension. To find the force of the push in the x dimension, we'll be using cosine theta because it equals adjacent over hypotenuse. In this situation, adjacent is force of the push in the x dimension, and hypotenuse will equal force of the push. To find cosine force of the push in the x dimension by itself, we'll be multiplying force of the push on both sides, which will cancel right here, and we'll get force of the push right here. That will make force of the push in the x dimension by itself. Now that we found the force push in the x dimension, we will find the force of the push in the y dimension. To find the equation of the force of the push in the y dimension, we will be using sine theta. To find sine, it is opposite over hypotenuse. Opposite is force push in the y dimension, and hypotenuse will be force of the push. To get force push in the y dimension, we'll be multiplying force of the push on both sides, which will get force of the push in the y dimension by itself.
Wake up, Mr. Webb! Mr. Webb! Mr. Webb!
Yeah. 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 And I heard him say, nothing's ever promised tomorrow today. From the shy, like Tim, it's a harder way to the